So question 14b has a number of parts to it. So if we just quickly look through them, we can get an idea of what they're trying to get us to do. So the first part, we're finding the exact value of this region on the cos curve. The second part, we're using a Simpson's approximation. And the third part, we're trying to show that pi can be approximated using this fraction here. Okay. Let's do part I. Okay, so we need to find the exact value of this integral. So I'm just going to write the integral out between pi on 3 and 0 cos x dx. Now, when we integrate cos x, we just get sin x, so that's pretty straightforward. We need to put our limits in, which is pi on 3 to 0. So this part's actually pretty straightforward. We get sine of pi on 3 minus sine of 0. So sine of 0 is just 0. Sine of pi on 3, we could use our triangle if that's how you prefer, or you just memorize it. Seen this triangle before. That's pi on 3 there. Our right angle triangles for our identities. So sine pi on 3 is just going to be root 3 on 2. So opposite over hypotenuse for sine. So we get root 3 and 2. That's just going to be 0. So for the first part, that's going to be our answer. Root 3 on 2 is the exact value of the integral cos of x between pi on 3 and 0. All right, let's move on to the second part. We're going to use Simpson's rule to approximate the same integral. Okay. So we also need to remember that our answer needs to be in terms of pi and root 3. So for Simpson's rule, we need to remember what it's actually doing. So if I drew a quick curve, so whatever that curve is there, let's call it f. This is x, this is y. What Simpson's rule is doing is it's fitting a parabola like that between, or 3 points actually, so it'll fit it like that, and then finding the area underneath. So to do it, you need 3 x values. You need x1, x2, and x3. Okay, so for us, that's going to be 0 is going to be the first x value. The second x value is going to be halfway between the two, so pi on 6. And then the final value is going to be that n1 pi on 3, okay? And the values that we put into the formula are the y values at those points, okay? So that's just going to be this curve here. F in our situation is actually just cos of x, okay? All right, so let's get started. We've got this integral that we've been working on. And we're going to use the Simpson's rule. So the Simpson's rule is the distance between x1 and x3, which for us is just going to be pi on 3 minus 0, all over 6. The y, or f of the first value, so for us that's just cos 0, plus 4 times f of the middle value, so pi on 6. So we're just going to have 4 cos pi on 6. And then we're going to have the last value, so the last y value, which is just going to be cos of the last x value. So cos of pi on 3. Okay, so we get that. So we can simplify this a bit. We get pi on 18 out the front. Cos of 0 is just 1. Cos of pi on 6 is root 3 on 2. You can do that using the triangle that we used in the first part of the first question. And then cos pi on 3, that's just going to be a half. Okay, so if we simplify that all out, we're going to get pi on 18 out the front, 3 on 2 plus 4 root 3 on 2. And there you have it. That's the answer to the second part. Now, for the last part, I mean, you could simplify that a bit, but we're going to muck around with it in the last part, so I'm just going to leave it like that for the moment. So for the last part, we're going to have to use part I and part II to show that pi is approximately equal to this. So the way we can do that is we found two different values for the integral. So I, the integral between pi on 3 and 0 of cos x dx, right? We have the exact value we used by integrating, and we also have the value we got using Simpson's rule. So what I'm going to do is I'm going to make those two equivalent, right? So we're going to say I1 is approximately equal to I2. Because if we go back and look at our answers, we've got a pi in here, and we've just got numbers in here. So if we make those two equal to each other, we can rearrange it and just get the pi on its own, okay? And that's what it's looking for. It's a pi is equal to some sort of fraction, okay? So let's see if we can make that happen. So on the left, I'm just going to have root 3 on 2, which is what we worked out with the integrating. And then on the right, remember to keep using the approximate equal signs. On the right, I'm going to have what I got in the previous question, pi on 18 root 3 plus 4, root 3 on 2. Okay, so I'm going to try and get this pi on its own, and we want to make it look like that. Okay, so firstly, I can take the 18 over to the other side. I get 18 root 3 on 2, approximately equal to pi. All this is still there. And now, give myself a little bit more room. Let's take this over to there. So, as you're probably all well aware, you can flip a fraction if you want to divide something by a fraction and times by it. Don't know if that made any sense. So I want to divide by all of this. So what I do is I just multiply this side by its flipped version. So it's going to look like that. Okay, so 2's cancel, and I get 18 root 3 all over 3 plus 4 root 3, which, if we just pop up here to the question, is what they were looking for. So problem solved. Okay, and that there is an approximation for pi. And there's all sorts of math tricks that you can do to find out approximations of these exact values.
Snack is an online platform to instantly create and share videos just like this one. To watch more or try a hand at making your own, head over to snackapp.io.